So here's a question that you might find a little bit tricky. Can you find the length of the triangle base? And here's one clue, the area is 9.9. Now your gut reaction might be to think that the area of a triangle is half base times height, which would mean that 9.9, which is the area of the triangle, equals half base times height, and then by moving things around a bit, you'd be able to get the base. Clearly that can't work, because if you move the height to the other side, there would be an unknown value, h, in the left-hand side of the equation, which means that the left-hand side would have an undefined value, and so we'd have no value for the base that was left on the right-hand side. If you know your sine or cosine rule well, you'd recognize that you can use neither of them directly in order to get this base, because for the sine rule, you'd need at least another angle for the equation to work, and for the cosine rule, you'd need the value of this side in order to get the base. But there is a way that you can work this out indirectly by using the information we have about the area. Now, I'm assuming that most will know that there are several different ways of finding the area of a triangle, not just with the base and height. And one of the alternative ways is by using the following formula, which is based on the sine rule. Half a times b times sine of c, where c is the angle between two edges of the triangle, a and b, that we have values for. If you're interested in why this formula is able to find the area of a triangle, I made a video previously which shows the proof, and I've linked the video in the description. Now, since this formula gives the area of a triangle, its value must be equal to 9.9. And now that we have this equation, we need to decide which edges of the triangle are represented by a and b, and which angle in the triangle is represented by c. Well, the angle is going to be easy because there's only one angle given, so c is going to be 81.9 degrees. And since in this formula, the a and b are represented by the edges either side of the given angle, then a and b must be the left and right edges of the triangle. It doesn't matter which edge is assigned A and which edge is assigned B. I'm going to assign the left hand side edge as A, so A must be equal to 4, and the right hand edge as B, which we don't have a value for yet. What I'm aiming to do is to find the value of the right hand side edge of the triangle. It may not be clear why we're doing that yet, but once we've done that, I'll explain why we need it. We know that the value of 9.9 represents the area of the triangle, so we can make more space by removing the clue, and we can show what the values A, B and C refer to in a key. We have the edge A and the angle C. Now let's solve for the edge B. We'll begin by multiplying both sides of the equation by 2. The 2's on the left hand side of the equation will cancel, and on the right hand side that gives us 2 times 9.9, which is 19.8. And that is equal to a times b times sine of c. We'll plug the values in once we've solved for b. Because all of the left hand side is a multiplication, we can swap a and b around. It won't make a difference to the value. So b times a sine c equals 19.8. Now let's divide both sides by a times sine of c. A times sine of c cancels on the left hand side, and that leaves us that b is equal to 19.8 divided by a times sine of c. We have the values for a and sine of c, so we can just plug that in. So that's equal to 19.8 divided by a, which equals 4, times sine of c, and c is 81.9. And if you run that through your calculator, you'll get that b equals this extremely long decimal, and it is so close to 5, I'm going to call it 5 for the sake of simplicity. And let's not forget to update the variables. And of course the edge b equals 5. And now that we have all of these values, we're going to use another method to find the triangle base length. Now some of you might be thinking that we're now in a position to use the sine rule to find the base of the triangle. But I'll save you the headache by telling you that the sine rule still won't work for finding the base of this triangle. I'll leave it as an exercise for you guys to find out for yourselves why it won't work. But there is another option for us, and that is that we can use the cosine rule to find the base of this triangle. The cosine rule comes in several forms. Here are 3 of them, each of which can be used to find the length of one of the sides of the triangle. If you look at the bottom equation, you can see that we're going to be able to find cosine of c because we have the angle c, but we also have a and b, which is 4 and 5, and we can use a squared and b squared, so that will give us c squared, and c is the base. So once we plug everything into the right hand side of the equation, we'll get c squared, and then we take the square root of that, and that will give us the base of the triangle. So if we apply all of the values to the right hand side, we're going to get the c squared is equal to a squared. Well, that's 4 squared, so that's 16, plus b squared, which is 5 squared, that equals 25, minus 2a times b. a times b is 4 times 5, so that's 20, times cosine of the angle C, which is 81.9 degrees. We can simplify that even further, because 16 plus 25 equals 41, minus, then it's 2 times 20, which equals 40, times cosine 0.9 degrees. And this will give us a value of c squared. And if we take the square root of both sides, we'll get that c, which is the base, is equal to 41 minus 40 times the cosine of 81.9. And if you run that through your calculator and round the answer up to 2 decimal places, you get that c equals 5.95. And that's the value of the base of the triangle. So that's one way in which you can work out the triangle's base. And if you came up with a different way, don't be shy, put it in the comments. I definitely read any suggested alternative solutions. Well, that's it for now. Thanks for watching.